Hi, my name is Darnie. I'm with Women Who Code, and I'd like to welcome all of you and thank you for coming. We have a food sponsor tonight. It's Austin Coding Academy, and I wanted to give them a few minutes to just give a brief talk. It's Luke and Joe.
Thankfully, that's awesome. Perfect.
Hello. Oh, this is great. So I get really nervous speaking in front of people. I hope you guys are cool with that. As far as the food sponsor, we actually have a ton of food that's like on the way. We have to thank this guy for the food that's here right now. But we've got a bunch of cookies, more sandwiches, and stuff like that. And as you guys saw, big gulp sizes glasses of wine. What we lack in food organization, we make up for in alcohol. But anyways, I just want to say thank you guys for having us here today. Thanks for letting us sponsor you guys. We've started to build a pretty cool relationship with Holly. I'm sure most of you guys know Holly Gibson. But we are a small coding school here in Austin, Austin Coding Academy. And we have our first session of classes are going to be starting in September. And we already have a number of members from the Women Who Code Meetup that are going to be joining us this fall. And it's really an amazing opportunity. One thing that we're really trying to focus on is expanding coding knowledge to not just your normal 25 to 35-year-old white male in the tech scene. And what you guys do here at Women Who Code is amazing. I think it's really, really cool because the reason why we started Austin Coding Academy is because we see coding as a pathway to really expanding your life financially and monetarily in terms of freedom as well too. And we're really excited to bring it to new demographics, to new landscapes, both in terms of here in Austin and in terms of the people as well too. We have two classes that are going to be starting in the fall. One is a survey course, and the other one is an in-depth Python course. And I'm just going to take a couple minutes just to real quick kind of explain the two of those, but the whole purpose is just to get people's feet wet and get into coding.
All right, I'm Joe, and I'll go ahead and explain the in-depth Python course first. So the in-depth Python course, obviously it's going to be using Python, and by the end of the course, you'll be able to create rudimentary, basic web applications that are capable of storing data, authenticating users, communicating with external services, and have some very basic front-end interaction where you can make your web pages interactive and produce some cool effects. So the course is going to be for 10 weeks, and my main goal with the course is to really pound in the fundamentals of programming. Really get people used to the foundations of logic, problem solving, debugging. I don't want people just to take cookie cutter and template applications and be able to replicate them mindlessly. I want people to be able to think clearly, communicate ideas, understand abstract problem solving. And those are the concepts that I'm most excited about. So I'm really excited about the in-depth Python course. The survey course is not so much understanding the fine grains of logic and critical thinking, but if you need to get a product out there quickly, you can accelerate that process using different services and external APIs, and we'll teach you how to communicate with those and also how to rapidly develop applications without that much coding knowledge, but we'll have some foundations in HTML, CSS, and JavaScript in order to kind of get you used to the ideas that different developers have, different technologies that different developers have to use and implement on a day-to-day basis. So if you're a co-founder, perhaps not as technical as you'd like to be, and you'd like to at least know what technologies are out there and what people are using, it'd be a good course to know how to develop the things on your own and also when to hire other people and what to hire other people for. So those are the two courses that we'll be offering, and I'm really excited about both of them. So I hope you guys check out our website, austincodingacademy.com, and check out the syllabuses and see what you think of them.
So yeah, thank you. Classes are going to be starting in the fall. Each class is 2 nights a week, and it's 6:30 to 9 each night, so it's meant to be part-time and something that you can do after work or after whatever else you have going on during the day. And they're going to be over at VUCA on South First. It's a really cool, beautiful space down there. But like Joe said, come check us out, austincodingacademy.com, and we got some business cards in the back as well too. It's got our phone number and website on there as well too, and
cookies.
And we got cookies. We're here. So anyways, again, please enjoy the food, enjoy the wine. You guys have an amazing speaker coming up, Adam, And I hope you guys have an incredible night. Thanks for letting us host with you guys.
Thank you. And here's Adam. Thank you so much for coming and speaking to us.
Sure, my pleasure. Let's see. All right, Samus and Metroid are not actually related to what we're going to talk about tonight. I guess I'll just get started. So this is me. My name's Adam Saltzman. I run a company here in Austin out of our spare bedroom called Finji Games with my wife Becca, who's up here. I'm a game and interface designer. And I've been doing this on and off for about, I guess, a decade now in one form or another, which is sort of terrifying. And today I'm going to be talking to you about this guy named Christopher Alexander. And I'm going to go a little bit Wikipedia here, but it's going to be totally fine. This guy was born in October 4th, 1936 in Vienna, Austria. He attended Trinity College at Cambridge, where he got his bachelor's and master's in mathematics. He earned the first ever PhD that was ever given to anyone by Harvard. Then he worked in transportation theory and computer science at MIT. He worked in cognition and cognitive studies at Harvard also. But he's actually best known for being an architect. And then, kind of awkwardly, is actually overlooked by a lot of architects in architectural history, which we'll talk about soon. But he built more than 200 building projects in California, Japan, and Mexico. And he's actually better known for his theory than his work in some ways. He had this theory of design as a decentralized, organic, inclusive thing. One of the terms that floats around his work a lot is user-designed. And I think a lot of people, when they think of user-designed, kind of think of the Simpsons car. But this, for example, is one of the user-designed houses that he sort of like supervised. It's a really beautiful place. And tonight I'm going to kind of be talking about two different books that he wrote. The books are called Notes on the Synthesis of Form and The Timeless Way of Building. Both of these books have been very influential in design and computer science and architecture. They've had a huge influence on me to the point where in reviewing and prepping for this talk, these are books that I initially read years ago, and there's stuff that I do now that I attribute solely to him that I forgot that this is where I learned that stuff. He's kind of the Bruce Lee of architects in a way, which is a really weird way to describe anyone, but I think you'll see what I mean in a little bit. So this book is called Notes on the Synthesis of Form. It looks like this. It's about that thick. And half of it's terrible, but we'll talk about that in a minute too. And it's a meditation on a problem, which is how do we get better at the process of design? This book is written by a guy who is really frustrated with the state of design and problem solving in the 60s. He's frustrated that new problems are being dealt with these like weird, arbitrary, like very formal styles that don't really have anything to do with new problems that are cropping up and kind of consistently more complicated problems. So he's sitting down to kind of like explore new ways to consider design and problems and solutions as like a field of study almost. The book is republished in 1971 with a foreword from Christopher Alexander saying, "Don't read this. This is a bad idea. Just wait. I'm publishing a new book that's better." But it's actually, there's a whole bunch of stuff in here that is still really, really great. And it's mostly from the first half and not the crazy second half. What he essentially says in the foreword is that all the conclusions in this book are wrong, but a lot of the language that he uses to describe the premise is really very good. So for example, he uses this word context, which he uses to mean sort of like the imperfect world around us, and it's kind of like a stand-in for the word problem. But it's also a lot more than that, because it's the problem, and it's the space around the problem, and it's the people involved with it, and it's like the world around it. And it's kind of everything that's exterior to something that he calls the form. And the form is anything that you make or design, anything that you create as a person, right? This guy, Darcy Thompson, describes a form as a diagram of forces and tensions. And we're going to go into that later more too. But a form in a lot of ways is basically a solution. And form and context together compose this single entity that he calls the ensemble. A lot of this is like kind of like slightly high concept, like 60s design magic, but it actually makes sense. Fit is another term that he uses that I really like. And it's essentially the way a comfortable shoe kind of conforms to your foot. A good solution should conform to a problem space. In Christopher Alexander's terms, then, a form should fit a context. And this is kind of the basic language that he uses for the rest of this entire book. And it's what he means by that is essentially a good solution. And so why bother, instead of saying, oh, it's important to come up with good solutions to problems, why talk about it with the language of, it's important that your form be a good fit to a context, is because what I like about it is it has this broader view. Rather than thinking about like, oh, I can't get this to work, I need to fix it, he's sort of implying that you need to step back and look at the whole situation and should that problem even exist, and is there something more intelligent that we can do? Quick examples. Tea kettle. The context of a tea kettle is like everything in the world related to, for example, the manufacture of the tea kettle. So factories, people, cost of raw materials, etc. It's also everything in the world related to the use of the tea kettle, which is people that make tea, the chemical properties of water, the size of kitchen appliances, and so on. The form is just the tea kettle. And the fit is how good the kettle is at being a kettle. Does the handle stay cool when you make water in it? Is it easy to fill? Is it cheap to produce? Is the design appealing and easy to understand? Is it constructed properly? Is it robust, etc., etc.? So if a form is supposed to fit a context, and that's our desirable goal or whatever, then if we can just describe the context or the problem we're trying to solve, then we've, like inadvertently or in reverse, described the solution to our problem. The context kind of describes the form, and the form describes the context, and vice versa, right? And that's the ensemble. So if that's the case, then how come design is hard? You should be able to just look at a problem and write down what all the real problems are, and then write down all of the solutions to those problems, and you're done, right? Not only is that like crazy and impossible on the face of it, you can't actually ever write down all of the problems with something, because the same object is used by different people in different contexts at different times. It's a completely impossible premise, which he acknowledges, and he describes design as the process of making forms for contexts that are impossible to fully understand. And that's why design is difficult in the first place. He has this great phrase, the experiment of putting a prototype form in the context itself is the real criterion of fit. What he means by this is, say you wrote down this great idea that you think is going to solve all of the problems, even if it looks really good on paper, until you actually put it out in the real world and see if it actually solves the problems it's supposed to solve. There's no way you can tell if it's actually a good fit for the context. Even then, let's say you do it. You make your thing, you have your prototype form, you've put it out in the real world, you're checking to see if it works. How can you actually tell if it's working or not? This sounds like a dumb question. You say, well, either it works or it doesn't. But there's actually, this is kind of where his background as a cognitive scientist comes in. He actually kind of like dissects this and pulls this apart. It turns out that when we're looking at something and we're trying to see if it's good at what it's doing, it's actually really hard to pinpoint the things that something is genuinely good at. It's really easy to pinpoint the things that something's bad at. Like you can sit in a chair and be like, this chair is fine. If you sit in the chair and it like explodes, you go like, this chair has a problem. Like we need to address this right away. His word for this is misfit. It's the ways in which a design parts of a design stick out and don't work, and those are the parts that are easy to find. A less insane example than exploding chair would be you sit down in the chair and like part of the back kind of like digs into your back a little bit. That's the only thing that you're going to notice when you first sit in that chair, and that's a case of misfit. If we go back to the tea kettle, we'd be talking about the handle gets too hot when I heat up the water. It's too hard to fill it up with water. It makes a mess when I try to pour the water out. Our tea kettle at home does all three of these things. It's so good. Maybe it dents easily when you're trying to just like do dishes or whatever. Maybe it was really expensive. It's really easy to like spot these things a lot of the time. There's another book that I have up here called Success Through Failure by Henry Petrosky that explores this. That whole book is just dedicated to this whole idea of why is it easier to spot problems? Why is it so hard to define when something works well? I don't have time to dig into it today, even though I would love to. So we kind of come to this really cool place after a while where we can go, oh, okay, cool, this is actually useful. A good form then is defined by a lack of misfit elements. If you build something, you build a chair, you sit in it, feels okay, nothing's jabbing you, it's not exploding, great, you have a pretty good chair, it's doing its job, it's being an okay chair. So he doesn't stop there though, and this is where I start to like, I'm a really big fan of this guy that's not coming through. So he makes what is like the first of many controversial claims that he's going to make over the course of his career, and this is where he starts kind of establishing himself as an outsider who a lot of architects are happy to pretend isn't a part of their field or whatever. He starts differentiating between what he calls self-conscious design and unself-conscious design. Self-conscious design, for the sake of brevity, we can refer to this as kind of like book learning. You're sort of like studying rules, you're learning forms and systems, you're taking lessons from masters. It's usually typified by like an admirable concern for quality, but also sometimes even an unconscious adherence to some kind of established style. It has connotations of being maybe narrow or compartmentalized or academic or superficial. And then he has this concept of unself-conscious design, which is more like self-teaching through trial and error. You try something, it doesn't work, so you identify the misfit elements, you fix them. You end up knowing lots of rules and lots of ideas the same way you would through self-conscious design, but they're kind of learned the hard way. And you kind of end up not having a style, you're sort of just doing what works. And it has this sense of being holistic and organic and fundamental. So quick asides on these ideas. So this Success Through Failure book has this amazing chapter where he goes through and explains that there has been a major bridge failure every 30 years for like the last 300 years. And 30 years is about the length of career of a working bridge architect. So essentially every time enough bridge architects and engineers have moved out of the field, somebody builds a bridge really stupidly and it just falls in the water. And this happens like every 30 years for a long time. And one way to view this is you have a lot of students coming out of architecture and engineering schools who have this really kind of deep self-conscious design attitude toward their work. They haven't learned enough things through hard lessons, and so they push the boundaries. And that results in really beautiful bridges, and some of them just can't stay up. So when a bridge falls, everybody learns a hard lesson. Everybody gets this kind of like crash course in unself-conscious design and starts making pretty safe bridges again. There wasn't one 30 years ago. It was a bridge that almost fell. But before that, it's every 30 years. There's this other guy, Russell Akoff, who's super smart, and he has this idea of doing things well versus doing things right, which is kind of similar. So a car company like Honda is really good at making cars. They make them efficiently, and their company is run well, and their employees are happy. But cars themselves are kind of terrible. They create an enormous amount of pollution and kill like an uncountable number of people around the world every year. So Honda, in Russell Akoff's terms, and this is an example that he would use, is a company that does things well, but maybe doesn't actually do things right. And what I like about this is it's, again, there's like this concern for the ensemble, or like the concern for a form or a process against this like broad human context. So a lot of established architects don't really like some of Alexander's ideas in this department, but I really like them because what he starts drilling down into is this idea of interconnections. And interconnections are, it's basically this idea that your form and your context is kind of fluid and constantly changing. You can think of interconnections as like dependencies. For example, if you remove a Jenga block, it's going to change the forces that are affecting all the other blocks in the tower, because all the blocks are kind of interconnected, right? Even though they're technically distinct. In the same way, if you were to cut into a single load-bearing element of a house, it's going to change the rest of the house almost immediately. We can go back to the idea of the kettle. This is a kind of a classic Don Norman design, but if a kettle is cheaply made, you're going to have to replace it more often. If you have to replace it more often, it's going to be more expensive to own in the long run. And so the quality of the kettle is now like entangled with the price. But if you want to make the kettle higher quality, it might be making it heavier or more expensive. But to combat those, you can then make the kettle smaller. But then you have to fill it up more often. And if it's kind of hard to fill up, then that part of using the kettle is going to get more annoying. And so this is kind of what it means for a form and its context, the way it's used, how it's actually put into practice, being interconnected or entangled or having these complicated relationships. So the meta problem of design then is actually really interesting. It's not the question earlier of, well, is the design good or not? There's kind of a meta problem about a design process, which is if we improve our designs by we make a chair, we sit in it, it's got a thing that pokes out, so we cut off the thing that's poking out of it, and now our chair is better. That's great, but what was that thing there that was poking you in the back? Was that a thing that actually makes the chair more stable and harder to break when you sit in it a lot? Because all of the elements of the things we design are interconnected, when you go and fix things, it has a tendency to break other things that are a part of it. It's kind of like design whack-a-mole. And this is not, so on our level, a lot of the time, if you're building like web apps or video games, this interconnections problem is can be interesting and frustrating, but in the real world, this is like a huge thing. So in 2003, there was an enormous blackout. It's called the Northeast Blackout of 2003. It affected about 55 million people, and it was caused by a bug in an alarm system in Ohio. There was a power overload at an electric plant. The alarm didn't go off because of this software bug. They failed to redistribute power, which triggered a race condition, which, quote, cascaded into widespread distress on the electric grid. The only larger blackout in history was in Brazil in 1999, at which point it was essentially a third world country, right? So this is like, this interconnected thing affects a lot of people constantly. It's just like a fundamental thing you have to deal with as a designer. So the meta solution that he proposes in here, and this is where he starts to disagree with his own later work or whatever. One meta solution to this meta problem of everything's interconnected, but when we change things, it messes up everything else, is to design things to have less interconnections, essentially. And you can kind of see this in a lot of things. The idea of things being modular and or redundant is basically this process in action. So if you have your mirrored RAID configured hard drives and one of the hard drives catches on fire, it's fine, you remove it and you put in a new one, the data is duplicated on the other drive anyway, it's fine. You have your laptop battery means that when they do the rolling brownouts for the AC here in town, your computer doesn't instantly shut off. You've got this backup thing in place. A lot of airplanes, an engine can stop working and the plane can kind of fly and land still, it's fine. It has a few other engines. You can replace lots of parts on your cars. That's a good level of modularity, but if you have like a tire blowout on a freeway, your car can still crash and everyone can die, and that's not good. The point being that it's kind of hard to get out away from interconnections in the way that he initially coaches. So, and a quick aside, as a game designer, interconnections are actually great. Like, game design is the process of creating problems for players to solve a lot of the time. So we're more in the business of designing context. So we love interconnections. We think this stuff is awesome. Anyway, the book starts to get kind of a little bit messy because after spending like 50 pages explaining why all these stodgy old formalist approaches are no good, they can't solve the problems properly, etc., he then spends 2/3 of the book laying out his own like arbitrary formal approach for problem solving, and there's these weighted graphs and this binary math system that is supposed to let you like calculate the degree of interconnectedness in any system that you build. It's super crazy. It's really interesting, but it starts to get like really beautiful mindy really fast. And there's a couple of problems outside of it contradicting himself or whatever. We have this basic problem of you can't define the world completely. The world in which your problem exists can't be defined completely. So why are you bothering to build this formal system for analyzing, completely analyzing a problem you're going to build if you can't even know what's going to happen to it when it goes out in the real world? And there's this basic underlying truth of things are always going to be interconnected, and what do you do about it? The solution to that isn't to make things slightly less interconnected. And so then that's when we get to this book. And this is basically my favorite book of all time. Certainly favorite nonfiction book. This book is called The Timeless Way of Building, and it was written about 15 years after Notes, which is about 8 years after the foreword to Notes is published to say, don't read Notes. It's sort of a lengthy preface to this book called A Pattern Language, which is sort of a hallmark piece of architecture literature. This book is an architecture book. This book, The Timeless Way of Building, is a philosophy book. And it talks about architecture a lot. And it's extremely weird. And this talk is going to go to a slightly weird place for a while, but I promise it's going to be worth it. This is a really well-designed book. It's actually 550 pages long. You can read it in under an hour because he's gone through and italicized every thesis sentence of every paragraph in the book for you. So the book is its own Cliff's Notes, which is kind of cool. And it follows all of his own rules that he's about to set out for what's interesting about design and problem solving. And I think it's a huge improvement over his earlier efforts because the system he's going to lay out fundamentally acknowledges this problem with we can't define the world in which our forms exist. And it gets weird really fast. So this book, it's a philosophy book. You can probably compare it a little bit to something like the Tao Te Ching by Lao Tzu, or sort of like any kind of like Zen. The book is all about this timeless way, which he's unable to describe, and the goal is to achieve the quality without a name, which he later does give a name, but it's sort of shorthand. It's so crazy. But the idea is that he's presenting a whole bunch of ideas, since he can't talk about this impossible to achieve thing because it's sort of like the meaning of life or human happiness. He has to talk around it, and so what he does is he builds this big structure around it that all kind of points in to this really valuable, powerful idea in the middle. And all these ideas that he builds in like a fortress around this idea that he can't really interact with directly, all those things are called patterns. And the goal of this book is to show the reader how to use these patterns to build what he straight up calls a gate to the timeless way. And the timeless way is a process of building through embryonic unfolding. And each step of this unfolding is a simple pattern or rule. And this unfolding process is the only way to actually achieve the quality without a name, this like Zen ideal that he can't actually interact with. But it's also not really a system of rules right near the beginning of the book, he says this. This is this amazing thing. He says, "Indeed, this ageless character we seek has nothing in the end to do with languages or patterns. The language and the processes which stem from it merely release the fundamental order which is native to us. They do not teach us, they only remind us of what we know already and of what we shall discover time and time again when we give up our ideas and opinions and do exactly what emerges from ourselves." It's not quite as self-helpy as it sounds, and the full text is all of these things, all of these kind of high concept philosophical ideas are supported by these huge piles of brilliant concrete examples from architecture. But I love this stuff. The quality without a name is this indescribable Zen ideal that we were talking about before. And he tries out a bunch of different terms and walks you through his thinking about why he's not giving it a name. And because in some ways he's talking about designs that are whole. All the pieces fit together and work together, but that doesn't really communicate kind of the human experience of being around designs like that, which tend to make you feel comfortable or relaxed. But that isn't really adequate because they also make you feel like free, like you're in a space that was really, designed for you. But that's not really, that makes it sound like you're just in like this, bounce house kind of environment, because there's a lot of precision to what he's trying to do. And what he ends up doing is, after taking all this time to explain that there's no way to name this quality, he kind of ends up naming it anyway, and he calls it alive. And designs or patterns that are alive are kind of mundane and natural and beautiful, and they're never the same either. So, and this is where kind of some of the Zen oppositions come in. So one pattern or one rule will never be exactly the same as another implementation or instance of itself. They're always unique in the context in which they end up existing. An example he gives is things like ocean waves or grains of sand. These things are all interchangeable at a glance. Like, you can't really necessarily tell two adjacent ocean waves apart, but they're actually completely unique if you get close enough. And they're perfectly suited to where they are, and they're a perfect reflection of all the forces in their environment. And since those forces always vary, if only slightly, the results always vary. And this is, especially to Alexander, a very natural thing and a very beautiful thing, and also a very sad thing, because nature is transitory. And Alexander says that to design naturally, we have to accept that things change and that things die also. And then he starts kind of grounding this idea, and he says, okay, let's look at the same kitchen in two different houses, the exact same kitchen layout, but the house it's in is completely different. These are no longer the same kitchen anymore, because spaces are influenced and changed by the space around them. And so when you're trying to talk about a kitchen or any kind of space, or you're trying to identify some kind of design pattern that's useful, you end up having to talk about the relationships between things. It's not enough to talk about the same kitchen, because they're not actually the same. But you can talk about a kitchen that's at the front of a house versus a kitchen that's at the back of a house, and those are things that you can differentiate and understand, and that have useful commonalities. And one of the things that's interesting about these things is that one of the reasons that you would want to identify patterns of relationships in spaces or objects or forms is that there's always a fundamental interconnection between these spaces and the events that happen in them. So a kitchen at the back of a house versus the kitchen at the front of a house is actually going to have different things happening in it, because the space around it is different. You have to walk different ways to get there, and maybe this kitchen is easy to get to, so you spend more time there, and so on. And so kind of like before, where we have this idea that a form and a context describe each other and are all part of the same ensemble, for Alexander, spaces or forms and the events that happen in and around them describe each other and inform each other. And so the thing that we're seeking out, the reason to have this framework in your head and to have all these crazy terms in your head is to have this goal of seeking out and learning and employing patterns which are alive. And patterns which are alive resolve all the forces that are in tension that are part of that pattern, like a form that is a perfect fit for its context. This natural, organic, holistic ensemble, right? Patterns are made up kind of like you'd expect of only other patterns. And so if you have a pattern that's whole, that means that all the patterns that are part of it are whole and stable and alive. So let's ground this a little bit. So my favorite example of his is this idea of in architecture and residential living or whatever, this idea of a window place. And he says a window place is a pattern which is alive, and then he explains why. So pretend you're in someone's living room for a long time. You've gone over to visit somebody and you're there for like 4 hours or something. Two of the forces that are acting on you while you're in this living room are wanting to sit and be comfortable because you've been there for like 4 hours, but also wanting to be near natural light. People are biologically phototropic. If there's a light side of the room and a dark side of the room, usually we're a little more comfortable on the light side of the room. You can imagine lots of reasons why that might be true. So if you're in a living room that has an alcove or a bay window seat or a low window with an adjacent chair, now there's a place where you can be in the living room where these forces that were in kind of tension previously can be resolved. You can sit in the chair by the natural light, and then you just kind of feel better. So the window place then is a pattern which is alive, and when it's part of a room, it helps the pattern of the room be more alive too. But if you're in a room that doesn't have these features, if you have to sit away from the light, or you have to stand near the light, and you kind of can't resolve these like conflicting desires, you kind of end up internalizing it, and it's sort of a state of like very low-level perpetual tension. This isn't something that like ruins your life necessarily, but it ends up being a problem because everything is interconnected, right? And patterns are made up of patterns. So patterns which are alive, like this window seat, tend to make the room more alive. But patterns which are the opposite, patterns which are dead, a room that has no natural light or a room that has no place to sit near the light, kind of affect everything around them too, but in kind of a weird indirect way. So, for example, maybe the living room is not a comfortable place to be, and so people will tend to spend more and more of their time in other parts of the house. And maybe those parts of the house aren't actually designed for people to be living in them most of the time. Everyone's spend all their time in the bathroom, right? It's not. And on top of that, everything is patterns of patterns of patterns of patterns. And so you have a house with an uncomfortable room, and the people that live in the house maybe aren't super happy in the house, and so maybe they're not keeping up the house as much as they want to, or they're not spending, they're spending more time outside than they would have otherwise, and it's having a small effect on the dynamics of the neighborhood that they live in. And the dynamics of their neighborhood are having a small effect on the city that they live in. And it kind of just like keeps going out from there. So how do these patterns actually work? I'm talking a lot about patterns and patterns of patterns and how important they are and so on, but so we were talking before about the timeless way, and the timeless way is this process of building through unfolding instead of building through addition or subtraction or something. And the example that Christopher Alexander gives is a flower. And a flower is not something that's assembled from its constituent parts, fully formed, right? There's not like a flower assembly thing that has the leaves that are all done and the petals that are all done. Flowers just grow from a seed. And they have an enormous amount of organic complexity, all of which is essential to the life of the flower, and all of which is actually impossible to create from the top down. You can't 3D print a living flower yet, right? But you can generate it indirectly through seeds and water, this like cooperation of autonomous components all working together to make this thing unfold and exist. You might call these kind of autonomous components patterns. And then the flower, if you just kind of let these autonomous components run, it just results in total chaos. So there needs to be some kind of overall pattern that helps all these pieces working together independently come together and create the shape of a flower. So For example, you could look at a farmhouse in the Alps. And farmhouse in the Alps is a pattern that is a collection of other patterns and functions a little bit like the genetic code of a flower. So each of these patterns is a rule, like make a farmhouse, or orient it this way, or add a second floor, put these rooms toward the back, etc. And so the actual pattern language or plan for a house in actual Christopher, using actual patterns that are in this book, he can kind of jot down this recipe for a farmhouse in the Alps, which consists of a north-south axis, a west-facing entrance down the slope, 2 floors, a hayloft at the back, bedrooms in the front, a garden to the south, a pitched roof, and a balcony toward the garden. And that's kind of all of the absolutely necessary components to describe the basic form of this house. But it's also kind of because it's a meta pattern, it's this collection of patterns, you can actually generate an infinite number of farmhouses. And every one of these farmhouses will be different from each of the next farmhouses, but they'll all share the same basic shape and the same basic features. And he does the same thing with this is a stone house in southern Italy, I think. Has a square main room, 2-step main entrance, small rooms off the main room, arches between rooms, conical vaulted ceilings, whitewashed walls. You can generate an infinite number of different houses that will all kind of look the same, but all also be very different. And you can do this because each of these patterns that he's proposed is a pattern that's alive. It's a pattern that makes people feel good to be around. And so when you combine them all, you end up with a house that is itself alive. How do you do that? What's so magical about these patterns? Patterns tend to be simple. They tend to be commonsensical. It doesn't mean that they're easy to notice. Especially when they're kind of in something like architecture, which is sort of an omnipresent part of people's lives. It can be really hard to pick these things out on your own. But even though they're simple, the effects they have are very complex. Back here on the farmhouse in the Alps, you have a very simple rule like bedrooms in the front. That's just kind of like a general rule. Actually figuring out where the bedrooms go and exactly how the bedrooms are shaped and how they open to the exterior are all things that are kind of up for grabs. And this is because these patterns are not really things or templates or rules or frameworks exactly. They're these bundles of reactive, context-sensitive relationships. And that's what allows them to come together and generate this kind of infinite variety of forms that still have these shared values or whatever. And so these are the sort of patterns that we use to build this gate to the timeless way. And this is what makes this timeless way, this process of building through unfolding, I think really superior to this idea of, well, let's just minimize interconnections or whatever. This approach embraces the fact that we can't really fully define the world around us. The timeless way, unlike his earlier work, does not provide a quantitative system of analysis or diagnosis, but it does provide an objective one, which is kind of interesting. Patterns do have sort of metrics or something, and the most important one is that patterns which are alive, these desirable patterns that work well, just feel good, which sounds like a subjective thing, but I mean, this guy's architectural career spanned 30 or 40 years, and for most of that career, he would, for example, say he needed to build a hospital complex, literally a hospital campus. He would go out there with doctors and nurses who worked there and just ask them through some very carefully phrased questions where they thought everything should go. And they would just tell them where all of the buildings should go. And they would put some sticks in the ground and kind of walk around and pretend it was a hospital campus and be like, yep, this is pretty good. And then they would build, a beautiful, effective hospital campus. It sounds insane, and it totally worked. It was a really remarkable thing. so there is some kind of objective thing. There is a real thing can happen where you can use something that's designed well and it makes you feel relaxed instead of panicky or feeling like you're using it wrong or feeling like there's just something wrong that you can't put your finger on. And so we want these patterns which are alive and which resolve these human conflicts. And it's also important for these patterns that they're flexible and that they adapt to the space around them for kind of all the reasons we've been talking about how we can't fully define the world around us and all that good stuff. So how do you test if a pattern is good or not? It's exactly, it's very similar to what we did in Notes on the Synthesis of Form, which is you perform an experiment. You introduce a form to a context, you check the fit. In this case, you follow a pattern, you produce a space or arrange a room or solve a problem, and then you check and see if it actually feels good. And so you go in and try the thing, and you don't worry about whether it adheres to some set of standards or some like aesthetic principle from outside. You just try it and see if it feels okay. And then you ask other people to try it. And then you ask them the same question. You don't ask them, what's your opinion about this? Or do you have any ideas about how we could make this better? You just ask them like, try this out and let me know if you feel good while you're trying it. And it sounds so unprofessional and it's so effective. So there's some other interesting things about pattern languages. They're kind of loosely hierarchical. And so you can define in architecture, there can be a pattern for a town which is full of house and street patterns, and the house patterns can be full of room patterns, and so on. And so there's this kind of inherent quality of managing complexity, which is sort of nice, and it allows this kind of like participatory design thing to happen, where you don't necessarily have to be like a GIS expert town planner with a master's degree in order to be able to point out things that could be happening that feel good or feel bad in the layout of a city even. Pattern languages tend to work from the middle out, which is very weird. I think, at least in game design, we talk a lot about top-down approaches and bottom-up approaches. And pattern languages tend to go from the middle out. Like the architectural pattern language that Alexander and his coworkers built starts at the house level, and then it works outward toward the town and like inward toward the interior of the home, which I think is sort of interesting. And because your pattern language ideally consists only of patterns which are alive and which people feel good using, and which are kind of these self-contained rule sets that are flexible and work with their surroundings. It kind of gives you this, and because there's this hierarchical thing going on where you only have to manage maybe a dozen of these things at once, you kind of have a chance to focus on the task at hand in a way that can be really difficult otherwise. So if you're planning a room, all you worry about is where to insert the other patterns you have. So you're looking at your living room, you say like, okay, we definitely want a window place, we need a second window, so we have two sources of light, and we need, it should be roughly a square, and it should have like a slightly vaulted ceiling, and all of those things, and the windows need to have small panes, and you can just kind of like figure out this basic set of things, and then you can just say, yes, this is all the things that this room needs to feel good. And then you can just be done with the room planning part, and you can go focus on making the window place really good, because you can have there's a sort of a level of trust or confidence that you can have in the previous step of your work before you've moved down to do the refinement. And that I think is really powerful. And Christopher Alexander's pattern language also has this vastly expanded notion of repair, which is not about regular necessary maintenance for him. For him, it's this like constantly evolving in small and organic and holistic ways toward this Zen ideal that we've been trying to achieve the whole time. So, things break and things need to be replaced, but repairs might actually be counterintuitive if you don't re-examine the current context of what broke and where and what's actually wrong with it. Maybe something broke because it actually was a dead pattern in the first place. Maybe it was kind of a living pattern, but the design in which that pattern existed has changed so much that it's out of sync, and you just need to come up with something different in its place. The timeless way of repair is this kind of constant and natural evolution, and not a maintenance of the status quo. It's it's more like looking for lots of little dead patterns and lots of little misfit elements, and then trying to figure out a way to get rid of all of those and replace them with something that's not just getting rid of that, but putting something back in that makes the entire thing stronger and more alive. So I'm going to attempt to summarize this guy's massive, amazing career, or the lessons that I take as a designer from his work anyway. The first thing is that the forms that we design have really complicated relationships with the problems that they're supposed to solve. One of the tools that we have is this idea of a language of patterns of relationships that can hopefully resolve forces that are in tension, that are created in us by the natural world, essentially. And it's impossible to do this. It's impossible to create a pattern which is actually alive by just acquiring a prefabricated object and inserting it into the pattern. It's because then you're not doing this process that is so important, which is building things by growing a design organically and focusing on making each step as good as you can make it before you move on to the next one. We have to kind of accept that every instance of every pattern is different, even if you try to do the same exact thing twice because you're doing it in a different place or on a different project or at a different time. What you do is going to be different no matter what. You might as well embrace it. And everything we make is transitory also. To paraphrase Heraclitus, change is the only constant in life. And I think at the very least, our designs should reflect that basic truth. And I think that's about all that that I have. I don't know if you guys have any questions about any of that.
So how do you implement all this into the work that you do?
That's a good question. So in my particular field, this is a book that a lot of, maybe not a lot of people like, but people look to this and go, oh, there's a lot of things that people don't understand very well about game design specifically, and so this is kind of one of the holy grails that people hold up and go, oh, if only we had this big recipe book and you could just look up all of the good things to do as a game designer, then we would all be fine. And we don't have anything like that, and nothing like that really exists, and I don't actually know of any effective pattern language in any field outside of this insane tome, which took a decade or two for 3 borderline peerless architects to compose in the middle of the century. I don't know if that means that it's impossible to do in other fields or if it just hasn't been done, but I think the thing that I take from it is this tendency to find patterns of my own and kind of collect them. And so my pattern language for game design right now is very small, but there are a few things in it. Things where I have sort of a collection of resources that can address certain kinds of problems. Like a core game design problem is a lack of interconnections. You can build something and players can solve the problem too easily by just flipping switches independently until the problem is solved, and they never have to really embrace the big picture. And so a piece of a pattern that's actually really alive in a game is this idea of when you put in something new, it has to be connected. Don't put in something that won't like instantly form connections with all the other parts of the game. It's just not worth doing. Like it ends up, for me, for the types of games I like to build, it doesn't work. It doesn't produce the kinds of results that I like. And that works in lots of different games. It works in action games and puzzle games and story games and all of the different things that we've built. So I think that's the practical thing. And I don't really have like a text file anywhere where I'm like storing my pattern language that or whatever that is like slowly growing. But the idea that there can be patterns like that that are, if not universal, are sort of a principle that you can use and hopefully eventually throw away because you'll just know, oh, this doesn't feel good. It needs to feel better. That I think exists.
I have a question about the bridges. I mean, I don't know if it's a question or more of an observation, but it's just surprising to me that somebody who's never built a bridge before would, be assigned to build a bridge, and that it would fail.
I mean, sometimes it's people whose dads built bridges. There's a lot of different things that happen, but a lot of it too is, I don't know, like everybody's heard of the nets they're building under the Golden Gate Bridge. It's been this long ongoing battle. Oh, we can't afford it, blah, blah, blah. This has been a thing that they've been trying to build for like 20 years. And by far the greatest opposition to it is they will make the bridge slightly less beautiful. And like the history of collapsing bridges is driven almost purely by aesthetics. Longer, thinner, more graceful, et cetera, and sometimes it works, but eventually it's usually the like every third or fourth really spectacularly beautiful bridge just doesn't cut it anymore. And it's because they've gone through and they've done all their formulas and they've done everything, and they'll bring in experienced consultant architects who will be like, that's gorgeous, but it doesn't feel right. I don't know what it is, but it doesn't feel right. And yeah, it'll go. It's a weird space. It feels weird to be in a technical field and to be seeking out like, I want to say guidance or advice about design, and to reach a point or find a point or have to acknowledge that at some point there's going to be sort of technical rules and technical frameworks kind of have a use but also have a limitation. In that they can be kind of distracting. Like all of these beautiful bridges that collapsed passed every engineering review with flying colors. There was always some excuse, oh, well, we're using this new kind of steel, the cables, that's way better than the old steel, so it'll definitely work, it'll be fine. But maybe that steel hadn't been tested in the temperatures where the bridge was gonna be built, et cetera, et cetera. So, those kinds of things are unavoidable to some extent, but there's something very appealing to me, all of that aside, to being able to refine and trust your instincts as a designer, to have, to not always make every decision with your gut, but to go ahead and make it with your gut and see if you are right or wrong, and then refine that instinct and to be able to use that to guide your work and tell if the thing you're building actually does work for people, and actually does make people's lives better, and actually is comfortable to use, and it actually does feel good to use. That's, it ends up being something that's really hard to put in really technical terms, but is also, seems really important. Anybody else? if you're interested, we're gonna stick around for a little bit, and if you want to like leaf through any of these gratuitous architecture tomes, I definitely recommend it. And I would recommend, as I may have hinted at earlier, this was sort of the like trippy, high-level philosophical view, which is stuff that's in this book, The Timeless Way of Building, but that's the top of the pyramid, and there's this whole enormous foundation underneath of concrete examples and cognitive science and all sorts of really interesting multidisciplinary things that sort of prop up in a more formalistic way this idea that you can build houses the way that a flower grows. So yeah, all right, I guess I'll hop down. Thank you for letting me talk here again.